Hey and welcome. Today we are going to solve can place flowers interview questions. This is one of the easy problems, so let's get into it. First example here. We have a flower bed array which only contains 1 or 0 elements within it, but the rule for placing a flower is that both of its left and right neighbors might be 0. If it was so, we can place a flower in between them. So we cannot place a flower in here or here, but we can place it here as we did based on the rule. On the other hand, we have another condition of n, which basically indicates that we might place n amount of flowers in the given array. If we can do this work, then we might return true. If not, then false. Second example. It is the same flower bed array, but this time we've been expected to place 2 flowers instead of 1. And based on the rules, we can't. Since if we place the first flower here, there's no other 0 element in this array that has 2 zeros to the left and right of it. That is why we are returning false in this case. Let's see how we are going to solve this problem. The basic idea for solving this problem that comes into our minds is we exactly need to implement the first rule as we discussed. For each element, if the element was 0, we might look into the left and right index of it to see if they are also 0. This is simply achievable by just an iteration over the flower bed array, and obviously in this case they are not 0, so we will move into the next iteration, which its neighbor's element are zeros, and we can place a flower in this case. But what about the other rule of n? For that, our job is also simple. We can keep track of how many flowers we place. Then, at the end of our function, we can compare the flower amount expected to be placed with what we have placed so far. And if they are equal, then we have the answer there. But let's think about the possible edge cases here. What if we could have placed more flowers than expected? I'm talking about a case like this one. We can place 1 here and 1 here. We already satisfied the rule number 2, right? We have 2 flowers placed. But since we only try to check for equality here, then we will return false. The solution is pretty simple for that. We should check if the flowers we place is bigger than or equal to the n. That should solve it. But what about the other edge cases? What if we get an array like this? Or even like this one. You see the problem here? If we have zeros in the edges of our array, regardless of we have some 0 values in one side as a neighbor, we don't have anything to the other end. And that might cause some issues for us. In order to consider this edge case in our solution, first of all, when we are checking for neighbors of an index, we might have some Boolean values indicating if the relative neighbor of right or left is 0, and if and only if so, then we will proceed with the placing the flower. But in case of edges like this, we will explicitly check for if we are in the beginning or end of the array, and if the other neighbor is 0. This will be much more easy to show you in the code. So let's jump right into it. First, we need to define our count variable and initiate it with 0. Then we need an iteration over the flower bed array. Now within this iteration, we need to do some stuff only for 0 values, because that is what we care in this step. As we discussed before, we are going to define 2 Boolean variables indicating if left neighbor and right neighbor of that index is also 0. For that, we need to check if values at i-1 and i+1 is 0. Then, if both of them are true, we might place our flower and increment the count value that we had before. And finally, check if the count value is equal or bigger than the given amount of flowers that we're supposed to place. But before running this function, you remember that we talked about edge cases where zeros can be at the beginning or end of the array, right? We are going to cover those cases in our empty left and empty right Boolean variables. If we are at the beginning of the array, since we don't have any value prior to where we are now, then i's value being at 0 also would mean that we have nothing in left. And it's the same for right side as well. If we are at the end of the array, then i's value being equal to the very end index of the array, that would mean that there's no element after that. Now seems like we are all set here. Now if I run this, test cases are passing, and if I submit, we are in a good shape in here. So let's jump into the time and space complexity analysis. So the time complexity will be O of n, since we just do a simple iteration over flower bed array. And the space complexity will be O of 1 constant, obviously, since we only just had a single variable count. So that was it for this video. Thanks for watching, and please leave a like, comment, and subscribe to the channel. I will put the link for arrays playlist and a few other ones in the description for you to check it out. And finally, hope you enjoyed this video and stay tuned for the next one.